Hello everyone, in this video we are going to talk about the utility system. We'll start by explaining the general principle behind a utility system and its strengths. Then we'll take a deeper look at the infinite axis utility system made by DevBlog, and finally I'll show you how it looks directly inside the engine. A utility system is a design pattern commonly used in game AI, whose core idea is to associate a score to something. That something can be an enum, a goal, an action, whatever you want. A classic example of utility system can be found in games that simulate emotions or needs, like The Sims. In our case, we'll assume that the utility system is used to score goals or objectives. The system maintains a list of possible objectives along with a way to compute a score for each one. It evaluates all objectives, then returns the one with the highest score. Let's take an objective called attack. This objective could look at a gameplay value such as the number of enemies in order to compute its score. That score is usually normalized between 0 and 1. For example, to convert a gameplay value like number of enemies into a value between 0 and 1, we normalized it. We might decide that 3 enemies correspond to 0 and 8 enemies correspond to 1. So if we currently see 5 enemies, the resulting score would be 0.4. From a design perspective, this means that our AI only really reasons between 3 and 8 enemies. Below 3, it's treated as if it were 3 enemies, and above 8, it's considered a lot of enemies. Anyway, things start to get more complex when we want to take multiple gameplay values into account. For example, if we want the attack objectives to consider not only the number of enemies, but also their current health level, this is where the infinite axis utility system introduced by DevMarks comes in. From now on, we'll call each gameplay value we evaluate an axis. For each score, we can consider an arbitrary number of axes. The real challenge then becomes how do we combine them? There are two important constraints we want to respect. First, a score with two axes, both valued at 0.9, should be close, ideally equal to a score with a single axis valued at 0.9. And second, if one axis evaluates to 0, then the final score should also be 0. In a utility system, a score of 0 usually means that the action, goal, or behavior is simply not possible. I'll put a talk in the video description by Graham titled Combining Normalized Values. If you jump to around 19 minutes, he explained this much better than I can, but the conclusion is the following. The geometric mean is the only solution that satisfies this constraint when combining normalized values. That's not my opinion, that's straight from Wikipedia. Now let's move into the engine and take a look at what this actually looks like in practice. I'll show you the classes that are used, how they're organized, and the debug tools that are in place. We are inside the engine. In the bot controller, you can see the decision maker component, but before that, here, there is the bot archetype. It is used to define weight for each goal. Weights are used as a priority or chance to arrive for the goal, and the list of goal list of actions, all the lists that you can see just are not final. It is totally in progress, and the system is quite advanced, but it is not tweaked, and all of the data are not there. Returning to our main component, we have a static priority for each goal, more for debug purpose, but if I want something to never arrive, I could just put 0 in it, and it will never arrive. In the input, you have the normalization data. So for each input, we have the min-max value to take in considerations. And in utilities, we have the decision logic for each goal. We have the consideration list, also could be called axis. And for each axis, we have a function or curve. It is a custom asset because I didn't want to use like the Unreal curve just to have basic functions. Today, I don't know if it was a smart way of thinking, because you can see that if designers want to directly tweak the function here and not create preset like that, I didn't manage that, so maybe it will change in the future. And I forgot something, and I added a choice logic here. Usually in utility system we get the best scores, but what if we don't want that in the future? So I added this enum to maybe get like a random on the 5 best or on the 3 best or just the best. I will play and show you the debug in order to show the system. We will let it play a little. So it should be okay. For debugging, it's extremely important to be able to record AI decisions over time. In AI, a bad decision might only have visible consequences several minutes later. To debug incorrect behavior, you need to be able to trace things back to the moment the decision was made. For that, I use the visual logger. It's really the programmer's best friend in Unreal. I haven't found a better solution than logging all relevant variables and relying on text output to visualize the results of utility systems evaluations. You can see there a frame of decisions, all the goals and their results. Here it is the normalized output, and there the axis results, and below the decisions of all the axes, and there down are all the goals with their utility score. You can see that for one goal, I have many targets and I compute the utility for each pair of goal and target. You can see that the best goal is form troops, and there with time, when you have enough troops to do something, the form troops goal will decrease and other goals which requires available troops will increase. And I have a NaN, so somewhere in my curve or data or system there is a quirk in mathematical computation. Outside my system, utility are great to have many behaviors where you can switch from anyone to anyone. You don't need to manage a big amount of transition like an FSM where all state could go in any state, and you don't need to bypass weird static priorities like in behavior trees. The systemic logic can also give some emergent behavior because it is the system that responds to the environment, and you can't really scribe that. It's not always a good point for the utility, depends on your game. That's it for this part. If you have any question about this system in BFME Reforged or about utility system in general, feel free to ask. In the next video, we'll focus on planning and how the objective selected by the utility system is translating into a sequence of actions that the bot can execute, or maybe about influence map. It is a system that I use for building placements. Thanks for watching.